We're going to study about transformers. Okay. So transformer is a static device. It is a stationary device and there is no rotating parts, only having a primary winding and a secondary winding and a core which is used for placing the winding. Okay. So it is a static device used for transforming electrical energy from one alternating current circuit to another circuit without any change in frequency. So transformer is used for transforming electrical energy from one circuit to another circuit, but the frequency will be always constant. Without any change in frequency, it is transforming energy from one form to one circuit to another, and it changes the voltage from high to low or low to high. So a high voltage level is changed into low voltage level. If the voltage is increased, then the correspondingly current will be decreased. So there will be corresponding increase or decrease in current. So if the voltage is increased, then we call it a step-up transformer. It is said to be stepped up. That is, when a voltage transferred from low level to a high level, then that transformer is known as step-up transformer. On the other hand, if it is decreased, then it is said to be step-down transformer. That means when voltage is transformed from high level to low level, then we call it as step-down transformer. Okay. And now we are going to study about different classifications based on applications and based on usage. Okay, based on application and also based on construction, etc. And there is and we are going to explain then EMF, induced EMF in a transformer, and what is the EMF equation, then the voltage and current relationships, and what is ideal and non-ideal transformers. Okay, so usually we know that the generated voltage level in a generating station is 11 to 30 kV level. So, but for transmitting that voltage level, voltage into our domestic purpose or industrial purpose, we need to increase the voltage level to reduce the high current. In 11 to 30 kV, the current level will be very large, so we have to use thick wires and constructional costs will be very high, and have to use different large power rating switches. So to reduce the construction or economically to reduce the cost, we have to step up the voltage. For that we are using transformers. So in for transmission system we use step up transmission, but we need only the voltage in either in 3-phase or single phase level, that is only for 15 volt or 230 volt. So we have to reduce that to 20 kV or 440 kV voltage level into a 400 or 230 volt level. So for that we are using step down transformers. So step up transformers are usually known as power transformers, and step down transformers are used in distribution systems, so we call it as distribution transformers. Okay. So based on applications, what are the classifications? Just we are going to study based on application, what are the classification. Okay. And before that, only on distribution at a domestic level is done by single phase transformers. Normally all other transmission system we use 3-phase transformers. So you got one classification based on the phase level. There are single phase system and 3-phase system. But a single phase system nu vechal endana, a single phase system have only 2 wires, one phase and one neutral. But in 3-phase system there will be 3 phase wires and one return path, only one neutral, or without neutral also we can work that 3-phase system. So single phase system and 3-phase system, for both of the system we have 2 types of transformers, single phase transformer and 3-phase transformer. But for transmission systems we use only 3-phase transformers, and only on distribution at a domestic level we need only low level voltages on domestic purpose. For that only we use single phase transformer, and it is done by that voltage step down is done by single phase transformer. Most of the power distribution in industrial level is on 3-phase system, Only exception is at railways. Some railway sometimes we use suburban trains, old suburban train systems which is used at Chennai or Mumbai. At old system, transmission level voltage is only 25 kV level. At that time we use in train system. You may know about, if you look at Mumbai or Chennai, very old suburban trains are traveling, which takes people from one locality to another locality of same state, which works in single phase, not in three phase. But all other industrial purposes we use three phase systems. Although power capacity is very high normally, 25 kilowatt level, which is used in railways, then we have to step down within the limit of that railway car or electric engine. Electric engine which is used in trains, which is called railway car. So we have to step down that voltage into its suitable level, and there is a converter. And how is it electrical engine works in a railway? There will be a converter which would be converting AC into DC. Converters are used to convert alternating current into direct current, AC into DC, and the DC motors are used. Normally, DC series motor drives the engine in the old systems. But in new systems, there is a transformation. There have been some changes into AC. In Western Railway, most of it converted into AC. But in Central Railway route in Mumbai, that is mostly in DC. Okay. So in railways, we are using DC series motors to drive the electrical engine. And in new systems, we usually use induction motors. So we converted that into AC itself. So at that time we use single phase transmission system. So single phase transformers are used in railways also. Okay. Then AC is transmitted, which is converted into DC and which drives DC series motor and then drives the electric vehicle. That is the basic working of an electric train. I just usually said what it is, the basic working done on the electric vehicles. Okay. These electrical vehicles have no return conductors. You know that if we just consider a train, you may see in electric trains there will be some U-shaped conductor and a overhead line going on the railway track, overhead line, and U-shaped conductor slides over that overhead line. And these electric vehicles have no return conductors. The return path is the rail itself. The railway track itself is the return path. Okay. The rail itself is a return conductor. And this road, which is a thick conductor, a big conductor, which is known as pantograph, and this overhead transmission line, which is insulated from that, and then over that U-shaped conductor, this U-shaped conductor, which is sliding over that overhead line lines to collect the current from the current to drive the electric engine. Okay. So I just explained only the basics of that train system. Okay, so in some railways we use single phase transformers, but in all other, most of the industrial purpose we use three phase transformers, and most of the application in domestic purpose we have to step down the voltage, so for that we are using single phase transformers. So in domestic purpose we use single phase transformers, and in industrial purpose we can say we usually use three phase transformers. Okay. Then we already told that in normally step-up transformers are known as power transformers. In transmission system we use a step-up transformer, so we call it as power transformers. Okay. So power transformer is functioning only when the generator is functioning. So in transmission lines, that is transmission line started from the generating station itself. Generated station which generates the voltage in 11 to 30 kV level, and that voltage have to transfer in a long distance transmission line. For that we have to step up that voltage. So that that function has been done by our power transformers. So power transformers are used in generating, either in generating station. So whenever the generator is generating, then the power transformer is on. If the generator is just turned off for some maintenance purpose, or if there any fault, we may switch off the generator, then the power transformer will not work. So if the generator is working or functioning, then power transformer is also in functioning. That means power transfer will be functioning only when the generator is generating voltage, and it will be functioning at 100% load to be the fullest capacity. So that means it transfer the voltage at its fullest capacity. Okay. Then distribution transformer. Distribution transformers are used in domestic purposes to step down the voltage. So step down transformers, you can see here, step down transformers are normally distribution transformers. So distribution transformer will be functioning in all the 365 days, because distribution transformers have to be energized in 24 hours. If one of the customer needs some power, then that transformer, if all other customers are turned off their load, but one customer need some power to work its work, then what the KCB cannot cannot turn off that step down transformer, because one customer needs that power, so we have to switch on that transformer in the 24 hours of whole days, so that we can say distribution transformers are functioning or to be energized in whole the 365 days and 24 hours. So all the time you should be turn on the distribution transformer. Power transformers can be turned off when the generating station is turned off, but distribution transformers will work in 24 hours. ഏതെങ്കിലും ഒരു കസ്റ്റമറിന് കുറച്ച് പവർ വേണം എന്നുണ്ടെങ്കിൽ മറ്റ് കസ്റ്റമേഴ്സ് എല്ലാം ഓഫ് ചെയ്താലും നമുക്ക് ഡിസ്ട്രിബ്യൂഷൻ ട്രാൻസ്ഫോമറിന് ഓഫ് ചെയ്യാൻ പറ്റില്ല. ഡിസ്ട്രിബ്യൂഷൻ ട്രാൻസ്ഫോമർ എനർജി സ്റ്റെപ്പ് ഡൗൺ ചെയ്ത് വോൾട്ടേജ് ലൈനിൽ വരുന്നുണ്ടെങ്കിൽ മാത്രമേ ഒരു കസ്റ്റമറിനാണെങ്കിലും ആ പവർ കിട്ടത്തുള്ളൂ. So for that, distribution transformer should be at on position for all the time. Okay. And transformers are also used for, so mainly we can say the main applications are in transmission system and in distribution system we uses transformers. Okay. So രണ്ട് applications ആണ്, as a power transformer and as a distribution transformer. Another application is transformer is used for impedance matching. What does mean by impedance matching? Impedance matching, why we are matching the impedance? That means we are transferring power from one source to one load. This one is source and this one is load. Okay, so there will be some resistance in the source side and there will be some resistance in the load side. So one theorem is there, a maximum power transfer theorem. It states that resistance or impedance of the source should be equal to the resistance of the load, internal resistance of the load, then that power source can transfer maximum power. Okay, whenever the source impedance, whenever the source resistance will be equal to the load resistance, then the power circuit will produce maximum power, or will transfer maximum power. So when we require to transfer maximum power, the internal resistance of the source and internal resistance of the load should be equal. So for getting maximum power transfer, the impedance of the transmission line system, the source system, that is XL should be equal to, XS source impedance should be equal to load impedance. So to make this XS is equal to XL, by proper turns ratio can be changed. You will get what is turns ratio. There will be primary winding and secondary winding. The number of turns N1 and N2. This turns ratio can be changed, and we can change the voltage level and also impedance level by changing the number of turns in primary and secondary. So by proper changing in turns ratio, we can make XL is equal to XS. That means load impedance is equal to source impedance can be made by changing proper turns ratio. So the transformer can be used for impedance matching also. And another one application is for using for isolation. Okay. What is isolation? Isolating from some source. That means there will not be any direct current flow in a transformer from 1 volt high voltage side to low voltage side or low voltage side to high voltage side. We know that a transformer have two windings, primary winding and secondary winding. These two windings are physically have no connection between them. They are only magnetic coupling between primary winding and secondary winding. So there will not be any direct coupling, or there will not be any current flow from high voltage side to low voltage side in a step down transformer. So from a high power, we can say there is no connection between a high power side to low power side. Okay. So transformer will not have direct coupling between two windings. It have only magnetic coupling. So we can say if, it is isolated, that primary winding and secondary windings are isolated from each other. So for example, for controlling the speed of a DC series motor or DC motors, ഒരു DC motorsന്റെ speed control ചെയ്യാൻ we may use some transistor drives. So by using transistor drives we can control the speed, and these DC series motors may be working on a voltage level of up to 1 kV level. 1 kV level voltage ലായിരിക്കാം motor work ചെയ്യുന്നത്, but the transistor drives are working on only 15 volts. So whereas motor working on 1 kV level, but the transistor drives working on 15 volt level. Okay, 1 kV level may also possible, so it may be different. So I must be isolated the motor and transistor drives speed control devices, because both are driving on different voltage levels, so we have to isolate both of them. So for that we are using isolation transformer. That is another application, and it can also provide, from this also you can get, it can also provide protection against fault in the high power side. So because of this isolation, only magnetic coupling is there, so we can protect the device from the fault in the high power side. And another application is measurement. The transformers can be used for measurement of high voltage level and high current. For measuring high voltage, we use potential transformers. Potential transformer is used for measuring high voltage. Okay. For example, if I want to measure a 400 kV level voltage in a transmission line, but I don't have any voltmeter having which is having a rating 400 kV. So what can I do? I have to step down that voltage to measure how much it is. So proportionally, I will find out the voltage level, and I use that step down transformer to reduce that voltage 400 kV to a measurable level. Then I can read that measurable level voltage by using a small voltmeter. So we have to step down the voltage to measure the transmission line voltages. So for that we are using potential transformers. It will be a step down transformer. Step down transformer. Okay. And another one is current transformer. For measuring high current measurement, it is only done for AC measurement only. For high current measurement, we use current transformers. Okay. And another one application is auto transformer or tap changing transformer. Actually, a single winding transformer is known as auto transformer. That means the primary and secondary are same in an auto transformer. We can say they have only one winding. Okay. I'm not representing the core, only representing the winding. And auto transformer is a single winding transformer in which primary winding and secondary winding are same. There is only difference is less number of turns is used as primary winding and more number of turns in secondary winding. Okay. So it is taking us either by tapping, by changing the tap points from the secondary winding. Okay. So this is done by tapping. We can say this one is tap 1 or tap 2 and tap 3. Okay. It is very much useful in generating stations and substations, because we know that in generating stations the voltage is generated in a particular level and which is transmitted. The transmitted voltage should be constant. If we are saying it is for example 400 kV level voltage is used.